that special water?
It's just deionized water, so it means that it's passed through some filters, so it's super clean water. So I call it the rig. It just means that it's just a load of pumps and pipe work, and it all works under pressure and high temperature. It's quite simple if we dumb it down a little bit. So we've got the water inside the kettle, which is being drawn up through this tube into the pump. This then pumps the water into the rig through this tube here. So this is just 16th inch pipe, it's really tiny, and it goes into the dampener here. Because it's a pump, there's a pulsing action with the water. So the dampener just acts to smooth that out. It then passes through a valve, which can be turned off to shut this part of the rig off, and then through a pressure transducer. So this just means that it measures the pressure, which is read out here.
That 3,080 something, what's that all about? What do those numbers even mean?
So this is the pressure in PSI, which means pounds per square inch. Now, if we look just up here, I have some pressure conversions for you. So 1 atmosphere, which is the pressure at sea level on Earth, is about 14.7 PSI. So at 3,000, you can see that's quite high. It's about 200 times the pressure here on Earth, which I think if you go about 2,000 metres under sea, it's about that kind of pressure. It's pretty high. So from this pressure transducer, the water then flows into the reactor. Now I have just over here a copy. So this is just a smaller version of the reactor. It's a coil of tube like this. So the water passes in through the bottom and comes out through the top. It's surrounded by this jacket heater, which heats the tube from the outside. And in the middle here, we've got a core heater. So this heats from the inside, which warms an aluminium block, and in turn, heats the tube.
That seems a really complicated way to heat the water, but I'll let you do it.
Thanks.
All right.
It's purely because we do it in an oil bath, but I mean, up here, you can see that the temperature of the water is about 360 degrees. It's still liquid, it's not boiling. Because of the pressure that we're maintaining at 3,000 PSI, it stays in the liquid phase.
How do you know that? You can't see in there. There's no window or anything. Is there a way to know, or you just know because you know?
We know because past people have done experiments, and people in chemical engineering study this quite a lot. So personally, I can't see it's in there, but I trust everyone else. So it passes out through this top bit, and it then flows to the back of the rig, which you can't really see, but it's right at the back of the fume hood here, where it meets a counterflow of cold water. So this means that the hot water is going this way, and the cold water, which is about 5 degrees, is passing this way. So if we move to the other side of the fume hood, so the water is just flown all the way across the back of the fume hood to be cooled. And then here, if you touch here, it's about 5 degrees, so that's really cold. It then passes through this gadget here, which is known as the back pressure regulator. And this acts to hold the pressure in the system. So if you imagine the water is flowing along and there's a needle sat in its way. So if the pressure behind the needle, so coming through the rig to here, is high enough, the needle is forced up and out of the way, and the water can pass through. But as soon as the pressure drops, the needle drops down and stops the flow. So you can adjust the pressure in the system by turning this, so you can increase it or decrease it quite easily. It is manual. Some of the others that we've got are electronic, but we like the simple things. It then passes into this injector valve, which can either send the water through here into waste, or in our case, recycle it back into the kettle. and you can see it's dripping out just there, and that's cold water.
And how long ago was it 360 degrees?
So the residence time in the reactor is about 2 minutes. So from this point here, where it's brought out of the kettle, it takes about a minute to get into the reactor, spends about 2 minutes in there, and about 2 minutes to get out. So it's about 5 minutes. So I work with high temperature water, not quite this high, but I'm trying to make plastics. So things like lucite or perspex, like this, are currently made from petrochemicals. I want to make them from biomass, which if you put it in high temperature water like this, it takes off CO2 and H2O molecules from the sugars that are fermented, and in turn creates monomers, so methacrylic acid or acrylic acid, which can then be polymerized, so they join up to form a really long chain of molecules, and that is plastic, like this.
Cool. How much does one of these cost?
I'd hate to imagine. This pump alone is thousands of pounds. So we've got 2 here. We don't actually use one of them. I do for some of the reactions that I do, but in this case we've not used it. But all in all, I'd guess close to £100,000.